We are student of BSc 6 and this is our A semester project for spring 2025. In this project, we have developed a machine learning system that predicts whether a car insurance company or car insurance customer is likely to file a complaint or not. This helps insurance companies to reduce frauds or like to take better decision and also offer their pricing according to the customer personal and regional data. So we have trained our model using real world dataset that came from that is from Porto Seguro. I don't know how to exactly pronounce this, but this is it. And then we have built a user-friendly interface in Flask that you can see here. Here we have okay, so here we have a front end where we can see we can analyze our data, we can pre-process our data. Obviously, we need to pre-process our data before to get good accuracy. Then we have a visualization which give us different plots. Then we have our model training feature that help us to model our data set on certain algorithms like random forest, ANN, KNN, linear regression, uh, logistics regression. So that there are a lot of models that we can use. But here I'm currently I'm using three data models. That is, I guess, logistic regression, forest, random forest, and ANN, or maybe KN. I will show you in like in short time. We can also do prediction. So, for example, we have trained our model, and some insurance company employee came here and put their details of the customer, vehicle, and other things. Then he will be able to know that this customer will claim or will not claim, like on the basis of the percentages. Okay. So then we have data analysis tab. There we have overview of our data set. We have a 60K data set, like rounding off. Then we have 59 columns. Also, there are different, if we see here, you can see the features are in this form underscore bin, underscore category, and like this. So, what we are doing is we are uh, distributing our feature according to bin, that is binary feature, categorical feature with underscore cat. Then we have numerical features like other continuous features which don't have underscore bin and underscore cat in there, like in the string or something like that. Then we also showing the graph like that target variable distribution, no claims and claims. After that, we have sample data, first 5 rows. Obviously, these are key insights that are telling us what we are doing actually with data analysis. So yeah, there is class imbalance which is handling by smart module. So these are helping us to analyze our data properly. Then when sorry, then we have data pre-processing. So in data pre-processing, it's showing us before pre-processing and after pre-processing, and also telling us this step we have applied. Basically, we replaced NN with -1. We imputed or added missing values with median or mod. So what we are doing is like checking up above value and below value and taking median or mode or standard value to fit in that place where we have missing values. Applied smooth for handling class imbalance. So I already told you that we are using smooth for handling class imbalances that we are seeing in our dataset. So after that, you can see it's before processing and after processing sample data. Then again, there is some techniques and details here. You can read this out. Missing value represented as -1 and Binary and categorical features imputed with most frequent values, continuous features imputed with immediate. Okay, so what we are doing is for the binary and categorical feature, we are actually uh, adding or imputing with the mode for the most frequent values, and for the continuous, we are taking median to handle like outliers. So obviously, we are getting median in our range so that our value don't exceed from other values or above or the below range. And then we have feature scaling. So standard scaler ensure all the feature have similar scalar for algorithm like SVM and neural network. There is class imbalance, so more sensitive minority oversampling technique. This is another technique that we are using. So what it is saying is there is most positive claims or maybe most negative claims or something. We don't have balanced classes. So for that we are using smooth, which generates synthetic example of minority classes to balance. Like that creates another a lot of more examples so that we can balance our positive claims and our other minority balance plus balance to balance the data set, and it's improve our performance on minority class prediction. So obviously if we have less negative claims or something else, we can say class, then obviously we are not getting a positive response or a good response from our ML when we search for that negative claims or something like for any other class. So we are not getting the we will not get a proper output. So that's why we are using smooth. So after we have visualization, we are where we are plotting the graphs. There are different graphs here. Let waits to the for the page to reload. Okay, here is the target variable distribution. Then there's missing value pattern. Obviously, we don't. I guess we don't have missing values. This is feature correlation matrix, which are showing the features. And okay, so after that we have visualization insights, which are telling us about the class imbalance, feature correlation, missing data patterns, and all that, which are showing above. Okay, so again, this is some other stuff. Prediction. If we go here in prediction, basically what we can do here is we can also train our model on the basis of the data set that we have. Currently, we have 60K 60K data set with the training set, train set, and with the testing data set also, so that we can check the accuracy of our model. Currently, we have three models available. Obviously, we can add more, but currently I have used this for demo purpose. And here we can select any of them. We can also train our model. So, for example, if I click here, it start training. So till that, we will like if I click here in random folders, and we have all the individual feature, regional features, car features, and all that calculated features. And same here, here we will get our prediction result. If I make prediction, okay, you can see here we have low risk, confidence 90%, model use random forest, and feature process 57. So here's the probability breakdown. Like 90% there are 90% possibilities that this customer are not going to claim, and 10% probability that this customer is going to claim for the insurance. So this will help our insurance company to like track the user on their regional individual feature, vehicle features, so that they are going to know their losses, handle their frauds, and also check for the good customers. Also, like for example, here I am training the model. The model is in before making this video, I have already trained the model. So we what we can do is we can also click on load saved model. So what it will do is it will load because of this process. It's little bit slow, and then we have logistic regression. So make prediction. Okay, three models has been import. Okay, when I did with low risk with regression, logistic regression, it has given 65% confidence, and they're telling us that this customer is maybe like 65% chances that this customer will not claim this. Then we have decision tree, and I can again do this make prediction. So 89.6% and claim 10.4%. So yeah, that's good. We will also wait for this to train so we can see what result we are getting after training the model. Uh, Also, I can fill this with random values, but that's give a problem. Like it will ask for enter less than five. Obviously, for right now, I didn't handle this in my program. So what you can do is manually get from the testing.csv test.csv, and there we can fix this problem. Like we can simply copy that. Okay, now I will explain how the code is working. It's our Flask code where we have firstly added all the imports, sklearn, numpy, pickle, os, and all that. For right now, we are using, you can see here, pickle to store the data. Okay, now if I go in bottom, these are some global variables to check for the model. Uh, this is simply checking the model folder. Okay, now we are loading the data sets. We are creating the sample data in case we don't provide them test.csv and train.csv. Okay. Then we are pre-processing our data where we are, I have already told you that we are distributing our features according to their characteristics. Not like these are binary features, these are categorical features, these are continuous features, which we like check by their last prefix or postfix. We can see postfix, sorry, which are hash underscore binary underscore cat. Okay. Then what we are doing is filling NA with the mod value. You can see here in binary and categorical features, we are filling missing values, not missing values, but obviously, yeah, missing values and NA and null values with mod value. And for the mod value, what we are doing is like we are taking the mod of that column and also and if not okay, so firstly we are taking the mod and also checking that if that's array shouldn't be zero. So okay, if it will be zero mean like if there is like null array or maybe empty array. Okay, so after that we are doing the same, taking median of these columns and then filling it with and filling the missing values with median value. Then we are going to train the model where we have added our three models: random forest classifier, logistic regression, and decision tree. Here we are iterating through the object model config or dictionary. You can say dictionary, and then what we are doing is training the model, uh, getting the accuracy by predicting from the X text. Here, obviously, we have X train, Y train. X train mean unknown values, and Y train mean known. Sorry, it quite opposite. X train mean known values, and Y train mean unknown values. So because of that, uh, we are able to train our model. So then we are giving the X tests. Obviously, in test we have known values, so we are giving the known values to check for the unknown values. Okay, so model dot predict probability. So we are getting the probability, we are getting the accuracy, we are getting the precision, we are getting the recall, we are getting F1 also. So here, after that, we are organizing our data in result dictionary with the model name as a key and value will be all the details, accuracy, precision, and all the details which are showing us after the data has been trained. If I see here, you can see I was showing you this thing. So in front end we are doing Ajax call. If I show you, You can see here it's load model basically train. Let's go on train. So here you can see it's doing post request on this API, and here we can see on response as a like response it's giving us end time and actual duration, and also it is giving us uh, response comparison plot. So it's given us comparison plot too, with also the accuracy too. So if we see here, it is telling us you have duration it take 257 seconds, model train 3, and completed it. That's not like an important thing, but then we have a decision tree, logistic tree, regression, and random forest accuracy. So here you can see we have 96.21% for decision tree, logistic regression 59%, and random forest 96. So decision tree and random forest are like most nearest accurate. Then we have logistic regression, which is not an accurate. Obviously, it's 59%. And also the time taken by decision tree is 40. For logistic regression, 6 seconds, and for random forest, it takes 210 seconds, 210 seconds. Then we have a graph plotted that is like showing the bars which has good accuracy and which has not good accuracy. So yeah, now I can also my model are again trained, and we can use that and make prediction. Okay, now let's go on app.py back, and here you can see then also here's like storing the vehicle using globally. Okay, load save models. Obviously, this is for if we have already saved models that we have trained the model previously, and we are only using this, so we can use load save models. Create plots, and these are simple. We are creating different plots using matplotlib and seaborn. Okay, then we have APIs for Flask where we are showing different data on different API. For example, data analysis, we are running data analysis.html, which is here, you can see, and we are using tailwind CSS. So yeah, here we have a lot of data. If I go to f.5 back, here we can see train data is not none. Okay, so this is also pre-processing our data. I have show you the function of pre-process data above. If I go there, this is a pre-process data which are distributing our features. Now I go down where for predict we are doing post request, and we are using this model, and then we are actually predicting the probability by model.predict and feature vector. So yeah, these feature vector are these features data we have. Okay. Uh, then we are returning them prediction, risk level, confidence, and all the details we need. Okay. Then we don't have any other things. So yeah, that's all. And then we have other HTML files that is showing the details, and rendering the HTML. So yeah, that's all. And also you like our project, and if you have any other question, you can also mention me in the comments or something like that. Okay, take care. Bye bye.